Hello everyone, this is Matthew Tucker. Welcome to this tutorial series on the Bifrost rigging module system, Autodesk's powerful compound-based system for building modular production-ready character rigs directly inside Maya. The rigging module system is a fully procedural and modular system built within Bifrost. At its core, it's designed to let you define rig parts as modules, each one encapsulating controls, joints, and transformation logic, all wired together in a flexible, scalable way. We will break down the system step by step, starting with the fundamentals and working towards building your own custom modules. By the end of this series, you'll be able to confidently create custom rig modules within Bifrost, publishing and reusing them across characters and assets. Building rigs that are both flexible and production ready, all while staying fully integrated within Maya. Now let's get started. We're diving into the framework of a Bifrost rigging module. At its core, a Bifrost rig is all about modularity and proceduralism. Each part of your rig is built as a self-contained module. A module defines a small manageable part of your rig. For example, you might have an FK module for your fingers and toes, a spine module with squash and stretch behavior, or a limb module that seamlessly blends from FK to IK. Each module handles the creation of the joint and control hierarchy and the transformation logic. Modules are designed to be connected through standardized ports. These ports are inputs, outputs, and parents. Pins are guide transforms to define the rest pose for your controls and/or joints. They live on the module's inputs port and drive what is called the pivot matrix, where the joint or control lives in world space when the rig is at rest. Because the framework of a Bifrost rig is procedural, you can move pins even after the animation has been added. The rest pose updates without breaking anything. This also means you don't have to recreate a bind pose for deformers like skin clusters. It's flexible, dynamic, and it saves you time. Now let's talk about transforms. Each module's controls and joints are driven by a shared core transform type. Thanks to the framework of a Bifrost rig, transform computation propagation is handled automatically. After defining rest poses with pins, the animation is driven via operator matrices. If you need a custom behavior, like inverse kinematics, you work in the user animation compound. After solving, all final transforms get pushed out through the output ports. And that's a quick overview of the Bifrost rigging module framework. Don't forget to explore the included modules and examples to get a head start. Whether you're building a complete character rig or just curious on how individual parts work, these modules are quite educational. And for a more hands-on example, open up the ARM module scene in the Bifrost browser. It is a great way to see how everything comes together.